Howdy folks, how's everybody doing today? Alrighty, happy Wednesday, hope you're doing well. So what's everyone up to today? Oh, I didn't have Desire to Learn. Oh, and I should fire up NetBeans first too. Look at that. We can get that started while we work on getting logged in here. That's right, awesome. That's really cool. Can't believe we're thinking about summer already. It is second week of March, right? Looking at classes for May. I guess that's not too bad, right? That's 7 weeks away. Classes in May. Not too bad. Nice. So in a couple more weeks, and they're going to have fall registration because reasons. Apparently, they doing early fall registration is supposed to be a thing. So I don't know. We'll see how popular that is, I guess. All right, so we're going to talk more about classes. Yeah, some exams. The exams are stressful. Hopefully. We can avoid that, and the midterm wasn't too bad, and that'll be our only exam. But other classes, I know their exams are rough. So we're going to wrap up Chapter 7, and then we'll talk about Project 3 today. And yeah, then when those are done, then fall. Yeah. And then we'll pick up Chapter 8 next week, and then we'll do arrays, and only the array list section from Chapter 12, and then we'll do file IO and exceptions, and then we'll do Java FX stuff. We got more Java FX, all sorts of fun things with Java FX. Time to work on the final project, and then we present our projects on May 2nd. So we're just chugging along here today. So let's see. Wow, that like started quick. That's really cool. I'm excited. So let me close all these down here. And then we'll go find our project. See if we can't get that to work here. Hey Crow, how you doing today? All right. Chapter 7 classes, where we left off. Tree class. There we go. Projects are always more fun. I'm definitely a fan of projects. Definitely projects. Okay. So we've played around with our tree class here. Now this here is a little bit tedious, and when we think about trees, and again, this is kind of going to depend on your class here and what we're trying to define. So it's not, this isn't going to be necessarily something we do every time, but it's very common here. When we think about our class here for tree, and we think about the attributes that it has, and we think about how we want to make an instance of tree here. Right. So far we've done this, we're calling it, this is the constructor method here. We're saying we want a new tree, parentheses. We don't actually know what is happening here, right? If we put this in debug mode here, and we debug our program, let's see if we can find out what's happening at this line. Just thinking about it here. Maybe we'll get some debug mode. Oh, sorry. Getting there. Just thinking about it. Okay. Enter the species. We're going to do like a maple tree with brown bark and, I don't know, 5 meters tall. Why not? Debugger is scary. Alright, debugger is definitely your best friend. Debugging is awesome. So here we are. This is our tree here now. Print debugging. Yeah, there's nothing. You can definitely print a bunch of things, but so now we have our maple tree. Let me bring this up a little bit. I can't make this one larger. It doesn't zoom very well. But here's the maple tree that we created up here, right? Using the variables that we were given, and you can expand maple tree here. So previously, all you had is like you can see what the values are, but you can expand it, and we can see its attributes here: species, height in meters, and bark color. You can see the values of those. You can see the values of those attributes here that belong to this instance of maple tree. Right? All right, so now we're at our line here. We're about to make a new tree here, our pine tree, and I'm going to do this step into, right? When we deal with methods and classes here now, when you are at the debug line, if we step over, it just does that. We don't get to see it run. So we want to step into. It says, okay, now we're in the class tree here. And the this here, remember, this is that special word for the current instance. So that's what we get. This height in meters is the class level attribute here, the green one here. And if we open that up now, I see species is null, height in meters is 0, and bark color is 0. So what happens is anything that is a primitive type, remember our doubles, our chars, our floats, our ints, those sorts of things, booleans, they're all going to default essentially to 0. Now, 0 is not a great default for a lot of these things, but it's a value. For something like a string, remember, a string isn't a primitive type. A string is actually a class all by itself. It's a reference type. It says, hey, here's where something lives in memory. Null is this special ugly value that means I don't exist. It's not an empty string. It's a I don't exist string. There is nothing in memory for me. So null says there isn't anything. Absolutely nothing there. So we're at our tree class, and then we're going to step, and that was it. So we go to the tree class and we get default values for all of our attributes here. And now we come back and we see our pine tree has been created here. And we can take a look at pine. One more line here to get pine tree. There we go. Now we get pine tree. So pine tree here again has those default values. Null. Hey, thank you so much for following along, my friend. We have 0 for height meters, and we have null for bark color. Now we're about to go fix them here, right? So if I can step into, I can see, hey, I'm about to set bark color. This is the current tree instance, which we were calling pine tree over here. Inside the class code, all we know is it's this. And we see the bark color argument we were given is brown. So now we see our bark color attribute changes to brown, because we said this.bark color equals the bark color argument. Cool. So that's all working, but that idea of creating an instance of this object with this tree line here. What happens behind the scenes is if you don't have a special method called a constructor, Java gives one to you. And what happens is all of these values default to null if they're reference types and 0 if they're primitives. So all the numeric values are 0. Booleans default to false, which is technically 0, right? Like 0 is off, 1 is on, 1 is true for Booleans. Chars, it's really a numeric value that defaults to 0 too. I don't actually know what character 0 is, but that's okay. So defaults are a little bit tricky. So what we can do is we can write our own constructor method. So constructor methods are special methods. Its job is how it creates an instance of the object. So its job is to create an instance of the object. Or of the class, right? To create an instance of the class, which is creating an object. So they don't have a return type. You just say public tree. So notice there's no return type here. That's how Java knows it's a constructor. And the name of it matches the name of the class. No return type. Name matches the class name. Matches. So what we can do here is we can give these things default values. Now, we don't actually know what a lot of these things should be. That's okay, but I can say species is an empty string here is going to be better than null. The bark color, you can say, is an empty string, and I mean, I guess height is fine at 0, right? Until we know otherwise, we can probably assume it doesn't exist and there has no height, I guess. I don't know if you want to count like a seed. Maybe a seed has height, and so by default, if you're a seed of a tree, it has, I don't know. I'm sure we could figure out something. But so we're going to give values to create that instance of the class. Means we are going to give values to all of the attributes. That's the constructor's job, to give values to the attributes. Now, before we had this, so actually let me go comment this one out real quick. I got ahead of myself. Where's my control? There we go. Yeah, control / we'll do this insert comment block somewhere, toggle comment here. So let me show you real quick. Nulls are bad. So if I make a tree and if I haven't done this set bark color yet, if I said, hey, if pine tree dot get bark color dot equals ignoring case brown, we can print out it's a brown tree. Right, just something silly, right? But okay, let's get the bark color. So my pine tree, right, dot get bark color calls the get bark color method, returns the bark color, right? And then we'll say, hey, does it equal brown? And we'll figure out if it's a brown tree or not. When we run this, excuse me, maple and brown and 5, we get, exception in thread main, null pointer exception. So null pointer exceptions I mean, you're trying to access something that points to null, that references null. You can't invoke equals ignoring case because the value of tree.getBarkColor is null. So we called getBarkColor. We got back a null, which means doesn't exist, not a thing. There is no string here, right? What is that line with Obi-Wan? These are not the droids you're looking for. Right? This is not the string you're looking for. Doesn't exist. Okay, that was a bit of a stretch. I apologize. That one hurt a little. Anytime I can do Star Wars references, I'm going to try, but so it doesn't exist. So I can't use a method like equals ignoring case on something that doesn't exist. There is no string here because we have null. So this is bad. That's real bad. This crashes if we use the default constructor that sets strings to null. Okay, but now if we go write our own constructor here, like we did, that says, hey, species is an empty string. An empty string is not null. Right? An empty string is a string that points to nothing. Right? Or it's a string that has no characters, but it exists. It is there. So I can say, hey, does an empty string equal brown? And obviously it won't, but it's not going to crash on us. So now when we run this here, it won't crash, and life is good. Maple and brown and 10 meters will make it really paltry, but it doesn't crash, right? Because now when we put the breakpoint in and we run this in debug mode, we'll see when we say new tree, this will go to the constructor, and we'll actually have code to run here. So maple and brown and 10. We're about to call our tree here. Oh man, friends, I can be famous. I just need to buy some followers, apparently. I don't understand bots. Like, who really clicks that stuff? What a waste of... You can go do something more productive. Anyway, so we're about to call this constructor line here. So we'll step into... Now we're in the tree class in the constructor method that we wrote. So a constructor is just a method. Yeah, people who scam other people make me super sad. Like, it's super depressing. They could be doing so many more productive things with their lives instead of trying to scam people. It's really unfortunate. All right, so now the tree constructor, we'll see I have values. Again, they start as null, 0, and null because that's what they are, but we're about to give them values. So now species is no longer null, it's just empty. Bark color is no longer null, it's just empty. Height is still 0 because we just don't have a tree, right? The height, I mean, sure. So sometimes the 0 is a fine default, but for our reference types, now we are no longer null, and it's much safer. So I will argue we probably always want to add our own constructor rather than let Java give the default constructor. So if you don't have a constructor written, Java gives you the default one. But if you write your own, then Java doesn't give you a default one anymore. Okay, so that's one thing we can do. The next thing that we can do, and again, a lot of this is going to depend on our class here, you can have more than one method of the same name. You can overload methods as long as the parameters are different. We can have more methods here. Now we haven't really done that with any of these ones here. Those are not super interesting. Excuse me. But let's see, how about our set height in meters? Why not? Why not? So just for fun here, we're going to make another method here. It's called set height in meters. So the name is the same. The arguments have to be different. I'm going to say a string for height in meters. So if you give me a string value for height in meters, we'll attempt to set the height in meters. Well, what we have to do with that, we have to turn this string into a double because we actually want numeric values because we don't want a string. We're just saying if you want to tell me what that value is as a string, I'll go do the conversion for you. So I can say double height in meters, or I don't know, height is double.parseDouble, given the height in meters. Okay. Well, now how do I go and set the height? I could just copy paste this, but remember, anytime you have the same code more than once, you should feel bad about yourself. So what I can do is I can call my own method. Remember, methods can call methods. So I'm going to call set height in meters given the height. I'll say, okay, you can give me a string here, or you can give me a double. If you give me the string, I'll go convert it to a double for you, and then I'll call my method that uses the double. So this is an overloaded method. Same name, different parameters. So the reason why overloaded methods are nice is it makes it easier for people to use our class. We're just giving them more options here. So if I'm going to my tree class, right, if I say pine tree dot, there we go. Now we're going to see two different set height in meters. We're going to see the string version and the double version, depending on what I give it here. So if I give it a string of like 10, it will call the version that uses a string. So at compile time, when we're compiling our code, right, we go to this compile option here, or when we run, it compiles. Java will say, oh, okay, you want the version that uses a string. Sure, no problem. It knows what that is because it knows the difference between a string and a double, or really an integer, but integers can be implicitly converted to doubles, right? It's okay to give it an int. We don't need a separate method that says an int is allowed because ints fit inside of doubles. So Java will do that explicit, implicit casting. We're saying, okay, really we can treat you as a bigger type. Remember what it won't do, it won't treat a bigger type as a smaller type. So if I have one that takes a int here and I try and give it a double, it won't do that because you could possibly lose some precision there, right? You could lose those decimal places. And anything over 2 billion or whatever, you might lose. So that set height in meters then just gives us kind of a nice, easy way. So maybe I don't need to do the conversion myself here. Right? Again, I don't know how useful it is, but that's an option we can do. This same idea that you can overload works with the constructors too. So I can write another constructor class here as long as I have different parameters. And a lot of times what we like to do, we'll call this a parameterized constructor. Parameterized constructor. I don't know if that's spelled right or not, constructor, but I'm making it up as we go. We'll make a constructor that has parameters. So I'll say, hey, if you give me a string for species, if you give me a string for bark color, and if you give me a double for height in meters, I'll take those values then, and I'll go do the thing with them. Now, species and bark color are simple. There's an E there? Parameterized. Okay, that makes sense. Parameterized. And maybe it's just my Michigan accent that we like to drop a lot of letters here. So I say parameterized and parameterized. That's a Midwest thing, I guess, right? That we drop letters and we shorten all of our words. Parameterized. I don't know. As long as you know what it means. So this setting the species and bark color perfectly fine. There's not any sort of logic happening here. I know if you say the word parameter too many times, it just loses all meaning. Parameter. We could make like a cool music video out of that, right? What we have to do is some sort of coding music video. That would be, I'm sure, wildly popular. That would make me famous, right? If I come up with a funny coding rap video. Bought instead of brought. Yeah. And we're particularly bad at that in Michigan, it turns out. And that's one of the things that you can tell Michiganders by their accent. Right? We always like to think we don't have an accent and everyone else does, but no, we have an accent. And we say sort of, what's it? We particularly like to leave off the last sound of letters. There's like a whole list of things that we say funny in Michigan. Oh, I'm not remembering it right now. Anyway, parameterized constructor accepts parameters. So we're just going to make it easy so you don't have to make an instance and then call a bunch of sets here. So I'm going to say, okay, so my species, my this.species equals the species argument. Great. My this.barkcolor equals the barkcolor argument. Great. Now, the last one is tricky here. I don't want to say my this.height in meters equals the height in meters. Right? I don't want to do this, because height in meters should have some sanity checking. Right? We want to make sure it's valid here. City. Oh yeah, city E versus, I don't know. So I don't want to do this. I want to call my own method set height in meters given the height in meters, because this one does the bounds checking. The method that does the bounds checking, or checks for that checks for valid values, right? So it's not overloading. I mean, so in our own, like here, when we just have methods, like public static methods in our program here, you can overload for sure. You can have a separate print tree if you wanted, but I mean, I don't know what else we'd give it other than a tree, so that one might be a little bit tricky. But now we can have two different constructors here. A set species, set barkcolor, and height here. Now, what's super nice about this one here is now when I go make my tree, if I know what it's going to be here, I don't need to, oh, that's right, we don't need that one there. I don't have to call these three lines here. I can say, oh, hey, it's, and I just need to remember the order here, it's species, then barkcolor. So it's a Douglas fir, it has brown bark, and its height is 2. And I don't need to do these lines. We don't need to call the separate set methods when we use the parameterized constructor. Right, so we will just have values for it right here in the constructor, which is fantastic. We run this one now, right? It's just saving us a little bit of typing here, right? This is a little faster to just give it arguments there. This was a maple, that was brown, it was 5 meters tall. And look, we have a brown tree now. So we made an instance here of a pine tree, gave it brown, and right off the bat we could check to see what its color was. Right? So the constructor is still doing the same job. It's giving values to all the attributes. Right? In this case, we're just setting them to the arguments we were given. We're saying, sure, okay, if you know the species, bark color, and height, we'll just take them here. So the next thing that this lets us do, once we have it here in the constructor, we can actually start getting rid of some of these set methods here. Right? We don't want a set species here. So we don't want this. A tree species never changes, right? Once you make a tree and you say, hey, this is a Douglas fir, it will never not be a Douglas fir. Now, again, this isn't going to apply to all classes, right? So this idea of not having a set method is if it makes sense in your class, right? If this is how we want to represent our objects, it's perfectly fine. So once you make that tree and you tell me, okay, it's a Douglas fir, it will forever be a Douglas fir. You're not allowed to change it. Right? So it doesn't mean every class has to do it, but if it makes sense for what we're trying to do, how we're trying to solve our problem, right, and how we're representing this noun, then great, we can do that. We've essentially made this value species read-only, right, because we're never going to change it anywhere else. Now, if we do this here, we don't want a constructor that sets species to an empty string because we'd never be able to give it a string here. So we actually, if this is the goal here, if you want to give it a value once and never be able to change it, you don't want one of these constructors here. So we can't use a default constructor if we have attributes with no set methods, right? Set star, whatever, you know, so star being like a wildcard, set this attribute. right? Because then you'd never be able to do anything with it here. So we need to move this line here. We can't do this one anymore. Oops. Oh, goodness. To down here. We can say tree, maple tree equals new tree, given the species, the bark color, and the height. Right? And then I don't need to call these set methods. So again, it's going to depend on what we want to do here. The height definitely will change, right? The species won't change. The bark color technically can change, I guess, maybe. I don't know if that's practical or not, but sure, why not? Maple, brown, 10, and we can still do all the things trees do, but now once you make your tree and you tell me what the species is, it will never change again. And now we get a little suggestion here. It's saying, hey, this field can be marked as final. So we looked briefly, right, this idea that you can make these named values, those constants. If you call a value final, it means you can set it once and never change it again. So it's telling us, hey, we noticed species only ever get set once here. Do you want to make it final to keep yourself from changing it again by accident? Sure, we could. Again, I'm not too particular about doing these sorts of things, but it's a good habit. If you're only ever setting it once, mark it as final so it can't be changed. That's a fine thing to do. We're not going to bother too much with that, but it's an option there if you want. Okay, so I think maybe our bark color could change as trees age or something. Maybe the bark color changes, so we'll leave that there. Okay? If it makes sense to our definition, and again, we're the one defining it. We're writing this tree class. We get a pick. Is it going to do what it's supposed to do or not? Right, that's totally up to us. All right, I started a pot of coffee like just before class was going, while my getting started screen was on, and I have nothing to drink right now, so I'm going to go grab my cup of coffee. Why don't we just take like a quick 5-minute break? Okay, while I grab my cup of coffee, and then we'll come back to it. We'll talk more about some of these things. Does that sound like a good plan? Put the music back on, because we got to go get that coffee. We'll be back at like 10:40 exactly. Yeah. Get that coffee emote. I'll be right back. Howdy, folks. Hopefully you got your coffee now. I am ready to caffeinate. This is like one of my favorite mugs, too. I love this one. I got it on a trip to Disney. It's huge compared to a regular mug. It's fantastic. Alright. So, our music player here. Fade that out all properly, right? Can't just pause it directly, you gotta fade it, right? Oh, look at that. That was fun. Very satisfying. Alright. So talking about classes here. Let's make another class here. Let's do another one. We make a class for, we'll say item. So let's come up with an item that we want to sell. So this class then will represent items that we're selling here. So first thing we want to do is come up with its attributes. So a private string for name, a private string for the SKU or the barcode, right? You know, everything that we buy and sell has this like fun little barcodes on them. And that's how we put them in the system and look them up and do all sorts of commerce and whatnot. I think they call them SKUs. And then we'll probably have a private double for, we'll say, the unit price. And we're going to have a private int for the quantity. Because you can buy a bunch of things at once, right? You don't have to say, hey, here's one, here's one, here's one. That's the worst thing about U-scans, is if you're like buying 12 packs of ramen noodles, you have to scan all 12 packs of ramen noodles. And it's so tedious. And you're like, I just want my noodles. Unless you can buy it in the box, like as a unit. But they don't always sell those packs of 10 or whatever that they have, and apparently ramen has been really hard to find, and then the supply chain issues with ramen, it's crazy. Like half the time when we go or we try and get it ramen delivered. SP Java classes like what? Well, so there's the cheap ramen noodles you can get at the store, or there's like the good ramen noodles, usually like restaurant quality ramen noodles. I'm talking about the cheap ones. Yeah, I mean, we're going to code all sorts of classes, for sure. All sorts of classes. Now, when we think about item, like the name of an item and the SKU of an item are probably not going to change. Right? So I want these things to not have set methods. Right? The unit price will definitely change. If we put this thing on sale, we're going to change the price. When it comes off of sale, we're going to jack the price back up. Right? Or if we think, you know, it's a good time and you know, the demand has increased, we'll jack prices up and gouge people. It's our store, right? We can do that sort of thing. This is so good. So good. It's so hot though. It's okay. And then the quantity will definitely change, right? Maybe I buy 5 of them and then I change my mind and say, really, I want 10 of them, or I have to put some back, and, you know, sure, that's all fine. So I'm not a fan of typing if the tool is going to type for me. So I'm going to right click and say insert code, and I'm going to say getter, and I'm going to check all these for getters. Get all the get methods here. So get name, get SKU, get unit price, get quantity. Boom, done. I'm going to add sets for unit price and quantity. So I'm going to insert code, and let's add a setter for unit price and quantity. Only those two, right? I don't want to change the name and I don't want to change the SKU, right? And now I also want to add some sanity checking. I want to say, hey, if my unit price is greater than 0, let's do this thing here. Otherwise, we'll set unit price, this unit price to 0. So if you try and give me a negative value, I'm going to say, okay, we must be getting rid of this thing, and we'll just give it away for free. But if you have a negative price and someone goes to buy it, we're paying you to take this off our hands? I don't think stores work like that. So again, this is our sanity checking, making sure that we're protecting the integrity of our class. We have decided what a proper value for unit price should be, and we're saying 0 or more. Okay? You cannot make the unit price be anything that is not 0 or more, because our code doesn't let you. That's fine. Same with quantity, right? We'll say, hey, if the quantity is greater than 0, great, we'll take your quantity, here. That one. Otherwise, this.quantity will just set to 0. You try and give me a bad value for it, a negative value, I'm going to say, nope, you can't buy negative of these things. I mean, maybe technically that's the returning an item is buying a negative amount of it, but we will pretend that doesn't happen because that just starts to hurt my head. And we probably don't need anything that complex. Okay, so nothing new yet, right? We can set unit price, we can set quantity, we can get all the values back out. Now, if we don't have set methods for name and SKU, we definitely need a constructor. And turns out NetBeans knows how to do that for you. You can insert code constructor, and you can say, hey, which arguments do you want here? And actually, I want all of them. Here, if you tell me the price and quantity, I'll take it here. Now, I don't actually want these lines here, right? Because I want the ones that do my validity checking. So I'm going to call set unit price, given the unit price, and I'm going to call set quantity, given the quantity. Right? I want to use my methods that we wrote that do that sanity checking. Right, so we're writing the parameterized constructor here. We don't have a no argument constructor because there is no way to set the name and SKU aside from the constructor. And this is generally pretty common, right? Depends on what you're doing with your classes, but you know, a lot of things that we kind of will think about and talk about in classes that we have, once you set particular values, it's possible they never change again. Right? So it's relatively common to have it as an argument in a constructor, and then it gets set once. Fine, nothing wrong with that. But other values, if they're supposed to change, or if it makes sense for them to change, sure, that's fine. We'll have set methods for them. Right? So it's not, you don't always have set methods for everything. Right? It's going to depend on what makes sense for our object. All right, so now we have item. Now the other thing we want to do with item. So far sets and gets were really boring, right? With tree, it was pretty boring, but they said, hey, we'll add a way to chop down that does something here. So for item, we're going to add a new method. We're going to add a public double get total price here. And then we're going to turn our quantity times the unit price. So if you say, hey, I want to buy 10 packs of ramen, and ramen are 39 cents each, we'll do the arithmetic for you. Thanks, cash register, right? Or whatever our application is going to be for this item here. Maybe some online shopping program, I don't know. Whatever we wanted to make it to be. So we've written a bunch of code here. All we have is the class for item. Okay? How do we know that it works? What would we do to make sure that it works? And make sure that, hey, I can't give it a negative value for unit price, I can't give it a negative value for quantity, and that I'm properly calculating a total price. What would we do with what we've learned so far? Right? Well, we would come over to our main method, and we'd start making a bunch of items, right? And we'd just do like what we did with tree. We'd give it some values, and we'd spit the values back out, and then we'd say, okay, I know I gave it this, so when I spit it back out and I print it, it should show this, right? That's how we kind of test our own code to make sure it does what it's supposed to do. We say, okay, if I give it this input, here's the expected output. Now, I hate to break your bubble, friends, but us humans are really bad at that sort of thing, right? If you've ever tried to proofread your own English paper, you remember how bad we are at this sort of thing, right? Because we have in our head what it should be already. So as we're looking at the output, because we're thinking what it should be, occasionally we miss things, right? And we're not so perfect at that sort of basic level, hey, if I give it this value, I get this back out, because we already know what it should be, and sometimes we're not paying close enough attention. So what we can do instead is we can make the computer do it for us. We're going to do something called unit testing, where the computer will test individual units of code, blocks of code, generally method by method by method, to make sure that it does what it's supposed to do. So you'll notice if you've looked at this project view, there's this thing called test packages over here, and it's always been empty. But now that we're doing classes, we can start adding test packages that test our classes. And the idea with unit testing is that I'm going to make Java do the testing for me, because it's much better at saying, hey, I gave you a 39-cent unit price, and I gave you a quantity of 10. Did I get out $3.90? right? We could do that. We can eyeball it, and most of the time we'll probably get it right. But we're not as good as computers are at that sort of thing. So we're going to make the computer do that unit testing. And unit testing is one of my favorite things because any code that's worth writing is worth testing, right? If you think it's important to write this code, it's important that it does what it's supposed to do, right? I'm hopeful that all of the work that you folks have done so far, you've actually tried and ran and saw if it did what it was supposed to do for our projects and for our labs, right? You didn't just write some code and say, oh, it probably does something, let's give it to Eric. Right? I hope that doesn't happen. I hope you actually hit the run button and gave it values and that sort of thing. But now we're going to make the computer do that testing for us. So I'm going to come to my class here. I'm going to right click on the class and say navigate, go to test. And it says, hey, do you want to create or update some tests? Yes, we want to create some tests. Now, because we're using Java with Ant, we need to make sure in this framework option, we pick JUnit 4. The later version of JUnit doesn't work with Java with Ant for reasons. It's not a big deal, so we'll use JUnit 4. So make sure you pick JUnit 4. Don't check any of the boxes over here on the right, and having these 3 boxes on the left is fine. So pretty much the defaults, but make sure we pick JUnit 4. That one's definitely important. Okay, and we'll say okay. It's going to generate a new class in the test packages folder here for us. Now we can go and test all of our code, and it adds a couple things here at the top. Don't worry too much about it. It adds methods for us based on all of our methods. So every time there was a method, it adds a test method. In this idea, we want to test one unit at a time. Here, testing get quantity, testing get unit price, testing get SKU, testing get name, right? So it sets up a bunch of these tests. And you notice that they have this at test. This is an annotation. It's just telling Java, hey, this is a test method. When I run tests, please run this one. That's all. So if we want to make our own test methods, we will also need to include that at test. Okay, so what we're going to do is we're going to test one unit at a time here now. So let's do get quantity. Why not? So what we do in test land, we follow this, and again, it's just a way, a pattern. We call this a convention. This AAA format or AAA convention. It means I'm going to arrange, which is set up all the values I need to test with. Then we're going to act. We're going to call the code we are testing. We are testing and get actual values. And then we're going to assert, did we get what we expected? So it's just a way of arranging our tests here. SP Java, generally I just have the videos. I don't have like separate documents. I mean like some sort of like screenshots with arrows and pointers and things. Generally I don't make those sort of things. Just go to your class you want to test, right click and say navigate, go to test. And then when they exist, it actually takes you to the tests there, right? There is no menu there. Like if we tried for tree here, right click navigate, go to test, it'll say, oh, you want to make some tests. And we just pick JUnit 4. Yep. Okay, so if we're testing our get quantity, what values do we need to test with? So I have a value that I expect to get back out for my quantity. So I'm going to call this the expected quantity. We said was, how about a dozen? Okay, yeah, sure. So mark it down, we're about 55 minutes in or so, 54 minutes in or so, if you want to come right back to the testing part. So our expected quantity is going to be 12. Right? That's what we expect to have here. Okay, then we're actually going to call the code we're testing. Now, so let's the other thing we need if we're going to test here is I need an item. So I need an item. Item equals new item. Now, item doesn't have a default constructor, right? It says constructor item in class item cannot be applied to given types. Required string string double int. Found no arguments. We have to call the constructor. Now, we don't care what the name was. We don't care what the SKU was, and we can just give it 0 and 0 here. We don't really care too much, right? No big deal here for getting quantity back out. But really, we know it's going to set a quantity. So why don't I give it the quantity here instead of the 0? So I'm going to give it my expected quantity. So I'm going to create that item here with the expected quantity. Now, what we're testing here is the get quantity method. So in the call the code that we're testing, I'm going to say int for the actual quantity, what does my item class think the quantity is here? We'll call the get quantity method. So this is the code we're testing. We're testing the get quantity method. Does it properly return a quantity that we give it? So we know our constructor gives it. We're going to test the set quantity later, which is a little bit funny because we know this one actually calls set quantity. Don't worry too much about it. Won't feel too bad. And then we're going to assert. We'll say assert equals my expected quantity and my actual quantity. Right? Did we get what we expected? Is the value that we got back out for the actual quantity, calling get quantity, is it actually the value 12? Right? And then I can right click and I can test my file here, and we get this really cool test explorer view, which is a nice visual view of did my tests pass or fail. And you'll see technically they pass if they don't fail. So test get quantity passed. Fantastic. Looking good so far. Now, I'm actually going to say this is a little silly here to test gets one at a time, because it's not really all that useful. And what we're missing here, you'll notice, we're testing get total price, set quantity. There's no testing for the constructor. So what I'm going to say is let's add a test for the constructor. So we'll say public void test constructor. And what I want to do here then is I want to actually do all of these all at once. So I'm not going to test get quantity, get unit price, get SKU, and get name separately. I'm going to say forget all those things, because I mean you could, and even get total price we're going to test separately. So all of our gets we're going to test inside of our test constructor, right? Because I know the constructor is setting values for all of those, and then I can go get the values back out all at once. So I think it's fine, and most people don't bother testing one get at a time. So we can test the constructor here. So we can have a string for expected name is ramen noodles. We can have a string for the expected SKU is, I don't know, like 1, 2, 3. I don't actually know what it is. And then a double for the expected price. I think we said was like 0.39 cents per ramen pack. And then when I make my item, I can give it the name, I can give it the SKU, and I can give it the price. Oops, expected SKU, that was weird. So now, the constructor is actually what we're testing. So I'm going to move this into the act section, because we're explicitly saying we want to test the constructor code here. That's what we're testing. It doesn't matter too much, but again, we want to try and follow this convention. We're going to set up all the values, we're going to call the code, and then we're going to see if we got back out what we expected. So I'll then go get, I'm going to run all the gets right here. Oh, and I also need the expected total price. So double expected total price is going to be, what, $3.90 plus 24 cents. So $4 and, oh my goodness. Okay, let me just do 10 because the math is hurting my head right now. So we'll say that should be 3.9, right? 39 cents times 10 should be 3.9 for our expected total price. So then we'll have a string for the actual name is my item.getName, right? We're essentially testing all of the gets along with the constructor. Get star methods along with the constructor, right? Because this is just going to make life a little easier here. Constructor for us. Okay, we get the name, we have a string for the actual SKU, item.getSKU. We'll have a double for actual unit price is item.getUnitPrice. Actual quantity, great, and then we'll have a double for actual total price, item.getTotalPrice. Excuse me. Okay, so now we need a couple more asserts. You can have more than one assert in here. We're going to just kind of double up here. So we'll assert equal or quadruple up. I forget what it is here. No, assert equal. And now you always want the expected and then the actual. So the expected name and the actual name. Right, and then we'll assert equals the expected SKU and the actual SKU. And then we'll assert equals the expected price and the actual price. We'll assert the quantity, actual price, oh, actual unit price, sorry. Sorry, so that's fine. That's fine. If we didn't call it unit everywhere. Quantity, and then we'll assert equals my expected total price and my actual total price. My actual total price. Okay, and these are done. So let's give it a run here. Let's test our file. Let's see what it thinks here. Oh, it fails. So remember when we talked a while back about how Java is bad at arithmetic with floating point numbers, with doubles, and like sometimes you get that trailing millionth decimal place somewhere? So when we're asserting equals on floating point numbers, you have to give it something called a delta, which is how close is close enough. So we'll say, hey, as long as you are within like a millionth of each other. Here, and that's tenths, hundredths, thousandths, 10,000ths, 100,000ths, 1 millionth. As long as you're within 1 millionth of the other number, we'll say that's close enough to be equal. So this is when comparing doubles, you need a delta. How close is close enough? So quantity, because it's an integer, really easy, no problem here. But total price and actual price, or unit price, are doubles, so we need this delta here. So we're telling it, okay, as long as you're close enough here, if you got that trailing billionth, we don't really care. Not a big deal. And now we run our test, and it passes. So our test constructor works here. So again, we're testing the constructor code. The constructor's job is to set values for everything. And part of setting the value for us to test if it worked is we're going to call the get method. So I generally will loop all the get methods in with the constructor test here, because we don't need separate methods, and I'd have to copy paste a bunch of things every time, and we could do them all separate if we wanted to. But I think this is much more practical, and what you'll see people doing is we'll test our constructor. Okay, now set unit price and set quantity here. One of the things that happens when we are working with unit tests is there's this idea of this concept called code coverage. So far, my constructor calls set unit price and set quantity. So if I were to think about this idea of code coverage, all that means is out of all of the lines of code that I have written, how many of them are actually running when my unit tests run? Well, I know that if I give it a positive value here, that this if block should run. So I know this particular line of code here at 25 runs, and I know that the block of this line of code here at 27 has not yet run. Right? We didn't give it a negative value here. So this line of code in all of my tests, one test, has not run yet. So what that means in terms of code coverage is I don't have 100% code coverage. I don't have 100% of my lines of code running while I'm testing. So code coverage is a metric. It's a one way of measuring, how intense and how exhaustive our testing is. Right? How are we actually testing all of our different code? Right? And like I said, any code that's worth writing is worth testing. If you don't care that it actually gives you a 0 instead of negative, then don't put this in. Right? But if you care that it gives you 0 instead of negative, we should test that it gives you 0 instead of negative. So we need to test for it. We want to test all of our code. We want to have 100% code coverage and make sure that all of our code is run at some point when we're writing our code. Now, there are some actual business trade-offs to this sort of thing here. I will definitely argue 100% code coverage is a fantastic goal. Not all organizations do it because it's expensive, right? To pay someone to go through every single if, else if, else if, else if, else if, else if block and test it can be expensive, right? You're paying for their time. Now, I would definitely say it's worth it, but at some point, right, testing most of your code is probably good enough. right? And that the investment that you're going to get out of it here, making sure that your code works. If you have to test every single case here, it can be a little bit expensive, right? Because generally software developers and programmers are paid a decent wage. We're definitely not minimum wage, on that pay scale or anything like that. But I'd say it's worth it. If the organization that signs your paycheck says, hey, you just test the common cases, go for it. We smile and nod. We say, okay, we'll feel good enough here. And, maybe more testing's better, but that's okay. So, and just because we have unit tests doesn't mean our code is ever bug-free, right? It's possible we've screwed it up twice, which I've done before. I screwed up something in, I was actually adding instead of multiplying or some silly thing here. Generally, like order of operations sort of bites me. That I did a multiplication before I did an addition that I was supposed to do, and then I tested it doing the exact same thing with the same slip. So just because we have unit tests doesn't mean our code is perfect, but it's much more likely to be perfect and actually do things correctly here. But it's not just having unit tests won't guarantee you that there aren't bugs in your code. Okay, so for our set unit price and get unit price here, I want to test here specifically that a negative, or I don't know, doesn't allow negative values. Same for my test quantity. Okay, so when I arrange, I'm going to have an int or a double for expected unit price is going to be 0. When I call my code here, I'm going to make the item equals new item given. We don't care about the name. We don't care about the SKU. The unit price, we should give a negative value here. And the quantity, we don't care. We can just leave the quantity at 0. And then we'll have a double for actual unit price equals item.get unit price. Now, the other thing we could do, it's probably more proper here. Let's just put it up here with zeros. And then we'll call item.set unit price, because we want to actually be testing this method explicitly. Now, I know that that method gets called in the constructor, so like if you did it in the constructor, perfectly fine. It's probably more proper here because we're explicitly testing that set method to call the set method. We know that the constructor does it, but this is probably more proper again. And then we'll assert equals that my expected unit price is the actual unit price within, 1/1,000,000th or whatever here. Is that probably enough? All right, so if I try and set it to negative, it should stay at 0. And we can run this test. It passes. Awesome. So the other super cool thing about tests is you can debug tests. I can put a breakpoint here, and I can say debug my tests. Right? And we can still use the debugger and step through our values here to see what's happening behind the scenes. Okay, then we can step into, and we can see, hey, here's my set unit price code. I gave it a unit price of -1.5. It runs the else block. Right, and then sure, continue on. So we can debug our tests. It's fantastic. So we're going to do the same sort of thing here for our set quantity. We'll have an expected quantity. We'll have a set quantity of, just say like -1, get quantity. And then our expected quantity, does it match the actual quantity? And then we don't need the delta here because they're ints. Right, so if I try and make it -1, it should just stay 0. Uh-oh. What did you do wrong? Quantity, get quantity. Oh, I have a double for quantity. I forgot to change that one here. So it was complaining about that same thing here where you're comparing doubles. Excuse me. It needs to be, oh, I am here too. That needs to be an int. Sorry. Yeah. So our test results failed. One more time, sorry. If they're both integers, life will be happy. This is what I get for copy pasting code. Now I've gone and felt bad about myself. All right, my test passes. Fantastic. Okay, how you folks feeling so far? Feeling pretty good? Okay, so what we need to do now is we need to talk about the next project. Project 3 is using classes and testing them. So notice I don't have anything in this main method that has anything to do with items. I just haven't done anything with them yet. The only thing we've done is we've written the class and the tests to make sure that it does what we expect it to do. Later we can go do something in main with it, right? And a lot of times in organizations, hopefully it's more than just you being the software developer, being the programmer or software engineer or dev, I don't know, whatever you want to call. There's all sorts of fun titles for us. Where when a team is large enough, right, you might do one piece of a project and someone else will work on another piece of the project. So you might never even run anything or have a main method that actually uses your class. Your role on the team might just be to build the class, right? And someone else is going to go use it. That's perfectly fine. There's nothing wrong with that at all. Okay. Now, the last thing I want to do here, I want to change my set unit price here. I actually want this to return a Boolean result here because I want it to return a true if it works. And if it doesn't work, we're going to return a false. Return false. Now, the reason is here, right? Our methods in our classes should never be printing things. There should never be a system out print line inside of your class code because your class has no control over where it gets used. If someone goes and uses it in a mobile application, I can guarantee you no one's looking at the console, right? If I go and use it in the web application, no one's looking at the console. If I go and use it in a graphical user interface application, no one's looking at the console. Right, so the class's job is not to spit things out to the console. It needs to communicate by returning values. And again, we'll talk when we get to exceptions about other things too, but we're not there yet. So I need to be able to return a value saying, hey, yes, this worked, or false, no, it didn't work here, so that when someone calls set unit price, we can see, did we get what we expected? So what I'm going to do then, I'm going to have one more test here. So I'm going to have a Boolean for result here, and then I can assert we'll say false, my result. So with just Booleans, we don't need an expected and an actual and say, hey, does true equal true? Same like in an if block, you just put a Boolean thing, so we can assert false or we can assert true. We'll say, okay, this one didn't work. We got back a false. Right, so it just gives us one last check here, and that way we can use that later. So someone else who's using my item class can say, okay, hey, if the user gives me a value and I hand it to your item class to set the price, let me see if it's true, great, we're good. If it's false, maybe we need to keep looping and say, oh, hey, something didn't work about your value here. Okay, that makes sense? All right, so let's talk about our project then. Let's go to project 3. New project. And don't forget, we have study group today, 12 to 1, right after class. Definitely encourage you to go if you can make it. The more you practice this sort of thing, the better you're going to get at it. This will be due in 2 weeks then, at 10 a.m. We'll do, oops, this is project 3. This is classes and testing. Okay, now we can add a grade item. Now it has a name. 4 projects. And I think this is probably going to be worth like about 15 points or so. We'll see, because the projects increase in points. And I have to remember how many. Actually, let me go look real quick. Let's go see how much those other ones were worth, because I'm forgetting right now. I think we see it on this page, right? Yeah, project, okay, 10 and 10. Okay, yeah, so we'll do about 15 points. It should increase in value here because we don't get to forget any of the other things we've done. So those points will just keep adding there as we go, okay? we'll say 15 points for this one. Essentially, we're using all the things from before, but now we're putting them inside of classes and testing. We need our GitHub Classroom link. We'll grab that for the project. Project 3. Go. So we're going to please submit the URL to your feedback pull request and a self-assessment using the rubric. Okay, so we're going to write a class called electric vehicle. All right, it will have attributes for make, model, and color. So as strings, right? So the make, the model, and the color are all strings. We're going to have a max kilowatt hours in battery and current kilowatt hours in battery as doubles. Right? You can store, I don't know, 37 kilowatt hours. Don't actually remember. I think they're like in the hundreds or 200s, I want to say. And then the current kilowatt hours in battery as doubles here. So we need get methods for all the attributes. We want a set method only for color. Okay. The only thing that changes in a vehicle here, and yes, the current will change. We'll get to that in a second. Is the color. Once you have a Chevy Bolt, it will never not be a Chevy Bolt. Right? Technically, the max kilowatt hours does change, but we're going to pretend that physics doesn't apply here. This is programming land. We're just going to pretend stuff. And we'll say the battery will always have the exact same max. I know it doesn't actually work like that, and eventually the battery degrades and that sort of thing, but we'll pretend, okay? We'll pretend. We're going to add a method called charge that takes a parameter of kilowatt hours to charge, right? And we're going to add that to the current kilowatt hours in battery. But we need to make sure the value is positive and our current kilowatt hours doesn't go above the max kilowatt hours. We're going to return a true result if we were able to charge successfully. Return false if it went above the max or was negative. Right, so yeah, I say, hey, I want to charge. So charge is how we're going to interact with this electric vehicle. We'll say, okay, hey, go charge 5 kilowatt hours. If our current kilowatt hours plus 5 doesn't go above the max, great. We're going to change our current, add 5 more. Right, we'll return true. If I say, hey, charge 50, and the max kilowatt hours was 20, we're going to stop at 20, and then we'll return a false. Right? You can't go above the max, so you can get to the max. Just like when you're pumping gas at a gas station, right? If you try and put 50 gallons in your tank will fill, but then all the extra is going to spill out all over the ground, right? Thankfully, our electric vehicles are a little smart, and we're not just going to waste electricity, but we're going to, we'll stop at the max and we'll return that false, saying, hey, it went above the max, it didn't actually work, or if you give it a negative value, it will return false here. Okay? Oh, we need one more value, I'm sorry. We need kilometers per kilowatt hour. So this is how many kilometers your vehicle can go per kilowatt hour. Okay? So far, I think the whole time I've had my Chevy Bolt, I'm at about 3.1 miles per kilowatt hour. And it really bothers me that it's miles because kilowatt is metric, kilo, right? That's the only thing we're actually using a sane system for measuring. So it should be kilometers per kilowatt hour, right? Kilo and kilo should use the same units. So we'll say how many kilometers you can get per kilowatt hour. Okay? So we have charge, and we'll add a method drive that takes a parameter for kilometers to drive. So we need to calculate the number of kilowatt hours required to go the distance, and subtract that from the current kilowatt hours. If it would go negative, stop at 0 and return false. Now we'll return false if the kilometers the drive is negative. If you were able to drive that far, drive successfully, return true. Right, so if you say, hey, go drive 10,000 kilometers, you're probably not going to make it 10,000 kilometers. So we'll stop our current kilowatt hours, we'll put it down to 0, and we'll return false and say, hey, it didn't work. Right? If you just wanted to drive 5 kilometers, great. And we were able to get, 8 kilometers per kilowatt hour. It uses less than a kilowatt hour worth of charge, right? Perfectly fine. Life is good. And then we're going to include unit tests for 100% code coverage. Okay, so drive and charge are how we're going to interact with the current kilowatt hours in the battery. Our kilometers per kilowatt hour, I know this one varies as well, but we're going to pretend it doesn't because it makes life easy for us. You get less kilometers per kilowatt hour if you're using air conditioning or if you're using heat. So my car works the best in the spring and fall when I can just have regular air pumping through the vents. When it's hot in the summer and I need to run the air conditioning, I go not as far. And when it's cold in the winter and I need to run the heat, I go not as far per kilowatt hour. And that's okay. Well, we're going to pretend it's always the same. And, the speed at which you're driving affects it too as well. Just like our regular vehicles, you get better miles per gallon in generally on the freeway if you're driving about 55 to 60 miles an hour, I think is about where most vehicles are most optimized. But again, that's sure, no problem. Okay. So that's going to be our project. All right. So let me put a rubric in here then. So let's do a rubric. Let me take out some of these levels here because these are silly. So if you're missing the feature, there's no points, right? If the feature is complete, there's points here. Feel free to award yourself partial points if you got it, but not quite everything here. So we'll have the electric vehicle class, private attributes, and public methods. Let's see. So let's do get methods here for all the attributes. So 3 points for that. We're going to do 3 points for the, let's see, what else? What other methods do we need here? Actually, let's and set color. So, and the set color will lump in there. So then we'll have the charge method. I don't know, just go back to the description, right? So 3 points for the charge method, 3 points for the drive method. Then we're going to add some more points here for our unit tests, charge unit tests, and drive unit tests. Okay, and unit test. All right, I'm going to lump all of these ones in together. I apologize, but they're like the test constructor is essentially this, right? This is our test constructor. So I didn't explicitly call out that you needed a constructor, but if you don't have set values, right? If you don't have set methods, you have to have a constructor. That's just implied that if there's no set method, it has to be passed to the constructor. Okay. So then charge and drive do the right things, and then you test charge and drive. And this overall score thing is nonsense as well. Overall score, sure. Okay, so that's the 15 points for this one here. All right. How's that feel? Think we can get this one done? Oh, I think my rubric didn't have a name there. Did I see that right? Yeah, it didn't have a name. Why? Why? Let's go rename it here. This is project 3. Got it. All right, so project 3 is the rubric. All right, so we got the rest of today to get working on the project. Did we have a lab? We had a lab from yesterday, or Monday, right? That we're also working on? Yeah, we had our lab, so you can get working on the lab if you're not done with the lab as well. Let's not double up here. I don't think we need more lab practice. I think we can just jump right into classes and unit testing the project. If you want to do exercise with unit tests, go for it. I don't think we need to like double up on the work here, if that's all right with you. We can go from there, okay? All right, don't forget study group at 12. If there's anything else I can do for you, let me know. And if not, we'll call it a day. Sound good? All right, awesome, folks. You take care. Have a good weekend.